Hello friends, myself Sonali Kanchan Rajendra. I am working as a junior college teacher in Rayat Shikshan Sanstha's Yashwantrao Chavan Institute of Science, Satara. Today, under this Rose project of 11 Science managed by Yashwantrao Chavan Institute of Science, Satara, we have to study very simple chapter from 11 Science, subject Chemistry, and name of the chapter is Adsorption and Colloids. This adsorption and colloids involve points, that is adsorption, types of adsorption, factors affecting adsorption of gases on solids, adsorption isotherm, application of adsorption, catalysis, adsorption theory of heterogeneous catalysis, and last one will be a colloids. This adsorption meaning always involve due to that surface chemistry. So first of all, we can discuss surface chemistry. So what is meant by surface chemistry? This surface chemistry, it is the branch of chemistry in which we study about those chemical reactions or chemical changes which are taking place at the interface of two phases, which can be solid gas, solid liquid, and liquid gas. That means there will be present two phases. One phase is solid and another one is a gas. In solid liquid, one phase is a solid, another one will be a liquid. And in liquid gas, one phase is a liquid, another phase will be a gas. This surface chemistry deals with phenomena that occurs at the surface or interface. That means surface chemistry deals with phenomena that occurs at the surface or interface. So what is meant by surface or interface? A boundary separating between two phases is called as a surface or interface. Many important phenomena noticeable among us, these being corrosion, electrode processes, heterogeneous catalysis, dissolution, and crystallization occurs at interface. The subject of surface chemistry finds many applications in industry, analytical work, and daily life situation. There are some properties of surface which are different from the properties of phase. That means, for example, the surface of solid or liquid has a strong attraction for the particles, that is atoms or molecules of the substance that come into contact with the surface. This strong affinity of surface for the particles result into the attachment of particles to the surface, and the phenomena is referred as a adsorption. There are many properties of solids, liquids, or solutions which can be explained by the action of their surface. In this unit, we will concentrate on the process that occurs between solid and gas interface. This unit is mainly devoted to adsorption, catalysis, and colloids. The use of solid surface is a catalyst. It is very important in chemical technology. There are other examples of adsorption may be considered. For example, when a metal spoon is dipped in milk and taken out, we can observe that a film of particles cover the spoon surface. Second example, if a cold water bottle is taken out from the refrigerator and kept on a table for a while, water vapor is seen to condense on the outer surface of the bottle, forming droplets or a film. The milk particles or the water molecules from the air gets adsorbed on the surface, that is the spoon and the bottle. That means here the spoon and the bottle act as a surface. Many surfaces of objects around us are exposed to the atmosphere. Water molecules as well as gas molecules such as nitrogen, oxygen from the air form an invisible multimolecular film on this object. This phenomena is known as a adsorption. So, here we can discuss the process of adsorption. Consider, here we can use a vessel. This vessel filled with a liquid, and here we can observe the two molecules. One molecules will be present to the bulk, that means atoms as well as molecules, and another molecule always present to the surface of a liquid. Here, that means here we can consider solid as well as a liquid. Consider a surface of a liquid or solid. The molecular force at the surface of a liquid are unbalanced or in unsaturation state. Similar in solids, the ions or molecules at the surface of a crystal do not have their force satisfied by the close contact with other particles. Why? Consider. Here, whenever you can consider bulk molecules, that means particles may be atoms or molecules present in the bulk of solid or liquid is surrounded by other particles from all sides. This bulk particle is therefore uniformly attracted from all sides by the surrounding particles. That is why particles in the bulk of solid or liquid have all their force satisfied by union with other particles. But the particles on the surface of a solid or liquid are different as compared to those in the bulk molecules. A surface particle is surrounded by other particles which are present on its side and below it is as shown in figure. As a result, the surface particles have their attractive force are partially satisfied. The attractive force on the upper side are unbalanced as there are no particles above the surface. Therefore, solid or liquid tend to satisfy their residual force. This force surface exert a attractive force on the particles of the species with which they come into contact and cause the species to be present at much higher concentration on them than in the bulk molecule. The attracted species does not penetrate deeper inside the bulk, but its concentration is retained on the surface, and this phenomenon is called as a adsorption. Here we can discuss point. Because of the unsaturation solid and liquid, the surface tend to attract the gases or dissolved substance with which they come in close contact. Thus, the substance accumulate on the surface of a solid or liquid. So, adsorption is nothing but the accumulation of molecular surface at the surface rather than in the bulk of a solid or liquid is termed as a adsorption. Or another definition is the phenomenon of accumulation of higher concentration of one substance on the surface of another than in the bulk, and that is called as a adsorption. There will be some examples of adsorption, like number 1, adsorption of gases like hydrogen, oxygen by finely divided metals, namely platinum, palladium, copper, nickel. Second one, adsorption of gases like nitrogen, carbon dioxide by activated charcoal. Number third one will be removal of coloring matter like an organic dye. For example, methylene blue. When we can dip charcoal to the methylene blue solution, and second, this methylene blue solution becomes colorless after some time, as the dye molecules accumulate on the surface of a charcoal. That is why methylene blue solution becomes a colorless. And this is a diagram how adsorption process maybe takes place. Next one will be why does adsorption occurs? The adsorption phenomena is caused by dispersion force. This dispersion force, always known as a London force or van der Waals force. This dispersion force will be short range as well as a additive. The adsorption force is the sum of all interaction between all the atoms. The pulling interaction causes the surface of a liquid to tighten like an elastic film. That means this is pulling interaction causes the surface of a liquid to tighten like an elastic film. A measure of the elastic force at the surface of a liquid is called as a surface tension. So what is means by surface tension? The surface tension is the amount of energy required to stretch or increase the surface of a liquid by a unit area. That means there is a tendency to have minimum surface tension, that is decrease of free energy, which leads to adsorption. Next will be, here we can say that adsorption must be different from absorption, which is defined as the phenomenon of uniform distribution of one substance throughout the body of another substance. For example, water vapors are absorbed by calcium chloride to form hydrate, but are adsorbed by silica gel. Ammonia is absorbed in water, but it is adsorbed by charcoal. Similar, in case of adsorption, there will be takes place similar some terms. Number one is adsorbent, second one is adsorbate, third one will be desorption, fourth one will be a sorption. So what is the means by adsorbent? The material or substance present in the bulk on the surface of which adsorption takes place, and that is called as a adsorbent. That means into that diagram, this surface in which adsorption takes place, and that is called as a adsorbent. Adsorbate, the substance getting adsorbed on the adsorbent is called as adsorbate. This is an adsorbate which gets adsorbed on the adsorbent. Next one will be a desorption. The process of removing an adsorbed substance from a surface on which it is adsorbed, that is called as a desorption. This is the example of desorption. Sorption, when both adsorption and absorption occurs simultaneously, it is known as a sorption. For example, when chalk is dipped in ink, ink molecules are adsorbed at the surface of a chalk, and the surface becomes colored, while the solvent of the ink goes deeper into the chalk due to absorption. Next point, we can discuss difference between adsorption and absorption. Here, number one, adsorbed matter is concentrated only at the surface and does not penetrate through the surface to the bulk of adsorbent. Adsorption is a surface phenomena. In absorption, absorbed matter is uniformly distributed inside as well as at the surface of bulk of substance. Absorption is a bulk phenomenon. Second one, concentration of the adsorbate is high only at the surface of the adsorbent. काय सांगितले बघा? Concentration of the adsorbate is high only at the surface of the adsorbent. And in case of absorption, concentration of the absorbate is uniform throughout the bulk of the absorbent. Third one, adsorption depends upon temperature and pressure. Absorption is independent of temperature and pressure. Number 4, it is accompanied by evolution of heat known as heat of adsorption. It is not accompanied by any evolution of heat. Next, number 5, adsorption depends upon surface area. Absorption is independent of surface area. Last one, 6 number point. Examples of adsorption. Adsorption of a gas or liquid like acetic acid by activated charcoal. In case of absorption of water by cotton. And second example is absorption of ink by blotting paper. Next one, the attachment of atoms or molecules of adsorbate on the surface of solids and liquids may be through two types of force may be exist, physical or chemical. Depending upon the types of force involved in adsorption, this adsorption is divided into two types. Number 1 is physical adsorption, that is always called a physiosurfaction. Number 2, chemical adsorption, that is always called a chemisorption. Here we can discuss the point physical adsorption or physiosurfaction. That means what is means by physical adsorption and what are the properties of physical adsorption. First we can discuss definition. When the adsorbents such as gas molecules are accumulated at the surface of a solid on account of weak van der Waals force, the adsorption is termed as a physical adsorption or physiosurfaction. These van der Waals force are similar to force causing condensation of gas into liquid. That is, heat is a released. That means whenever condensation of gas molecules takes place, at that time heat is released. And the van der Waals force are similar to that condensation of gas into liquid. Third point, heat released during physiosurfaction is of the same order of magnitude as that of the heat of condensation. Physiosurfaction is weak due to weak nature of van der Waals force. That means here physiosurfaction always a process is a weak due to why physiosurfaction is a weak, because here van der Waals force must be a weakest. The adsorbed gas forms several layers of molecules at highest pressure. The extent of adsorption is large at a lowest temperature. Equilibrium position can be attained rapidly. The physiosurfaction process is reversed by lowering pressure of a gas or by raising a temperature. Next point will be a chemical adsorption. It was first investigated in 1916 by American chemist Irving Langmuir. He can give some points about the chemical adsorption. When the gas molecules accumulate at the surface of a solid or adsorbate by means of chemical bond, be it covalent or ionic, the adsorption is called as chemical adsorption or chemisorption. Second point, chemisorption involving gas solid as the adsorbate and adsorbent. That means here gas is a adsorbate and solid is a adsorbent. And this chemisorption is exothermic. That means here heat is released, except the adsorption of hydrogen on glass is endothermic. Here heat is absorbed during the process due to dissociation of hydrogen. Third point, the heat evolved in chemisorption per mole of adsorbate is the same order of magnitude as that of chemical bonding. Number 4, chemisorption involves large energy of activation. So this chemisorption is always called as a activated adsorption. Number 5, chemisorption increases with increase in temperature. In the beginning, as more number of molecules can have activation energy as the chemical bonds break down. Number 6, at low temperature, physiosorption occurs, which passes into chemisorption as the temperature is raised. That means whenever temperature goes on increases, physiosorption which gets converted into chemisorption, because chemisorption depends upon surface area of the adsorbent. Next point here, what is the difference between physiosorption and chemisorption? Number 1 will be the force operating in physiosorption are weak van der Waals force, and the force operating are of chemical nature, that is covalent or ionic bonds. Second one, physical adsorption is not specific in nature. All gases adsorbed on all solids. For example, all gases adsorbed on charcoal. Chemical adsorption, highly specific, occurs when chemical bond formation is possible between adsorbent and adsorbate. For example, adsorption of oxygen on tungsten, hydrogen on nickel. Third, the heat of adsorption is low and lies in the range 20 to 40 kilojoules per mole. Chemical adsorption, higher heat of adsorption lies in the range 40 to 200 kilojoules per mole. Physical adsorption occurs at low temperature and decreases with an increase of temperature. Chemical adsorption takes place at highest temperature. The extent of chemical adsorption is lowered at very high temperature due to bond breaking. Number 5, for example, at low temperature, nitrogen gas is physically adsorbed on iron. In case of chemical adsorption, for example, nitrogen gas chemically adsorbed on iron at highest temperature forms layer of iron. Next point, that is factors affecting adsorption of gases on solids. Number 1 will be a nature of adsorbate. The amount of gas adsorbed by a solid depends on nature of the gas. That means gases having high critical temperature liquefy easily and can be readily adsorbed. The gases such as SO2, Cl2, NH3, which are easily liquefy and are adsorbed to a larger extent as compared to nitrogen, oxygen, hydrogen, and which are difficult to liquefy. Second one will be a nature of adsorbent. Substances which provide large surface area for a given mass are effective as adsorbent and adsorb appreciable volumes of gases. For example, silica gel, charcoal are effective adsorbent due to their porous nature. Third will be a surface area of adsorbent. Adsorption is a surface phenomena. Hence, the extent of adsorption increases with increase in surface area of adsorbent. finely divided substances, rough surfaces, colloidal substances are good adsorbent as they provide large surface area for a given mass. Number fourth one will be a temperature. Adsorption is an exothermic process according to Le Chatelier's principle. It is favored at low temperature. The amount of gas adsorbed is inversely proportional to temperature. Why? Because whenever we can plot the graph on x-axis, pressure may be given. On y-axis, here we can use volume of nitrogen gas adsorbed per unit mass of adsorbent at different temperature 195, 244 Kelvin to 73 Kelvin. As the temperature increases from 193 Kelvin to 273 Kelvin at constant pressure P, the amount of gas adsorbed decreases. And number fourth will be a pressure of a gas. At any temperature, the extent of gas adsorbed increases with increase of pressure. The extent of adsorption is directly proportional to pressure of the gas. At high pressure, the extent of adsorption becomes independent of the pressure as the surface of adsorbent is almost fully covered by adsorbate molecules. In this way, today we can discuss the points like number 1 will be a what is means by adsorption, what are the examples of adsorption. Next one, why does adsorption occurs, what are the terms involved in adsorption, adsorbent, adsorbate, desorption, sorption, difference between adsorption, absorption, what are the types of adsorption, physical adsorption and chemical adsorption, what is means by physical adsorption, what are the properties of physical adsorption. Next one, what is means by chemical adsorption, what are the points involved into that chemical adsorption, difference between physical adsorption, chemical adsorption, what are the factors affecting on adsorption of gases on solid. Number 1 will be nature of adsorbate, second one will be nature of adsorbent, third one will be surface area of adsorbent, fourth temperature, and fifth one will be a pressure of a gas. In this way, we can discuss these points. Next topic, next point, we can discuss what are the application of adsorptions. What are the application of adsorptions? Thank you.